So this video is just gonna go through some coding a little bit more in depth. A lot of this is going to be actually stuff that we've already looked at, but just a little more in depth, breaking it down step by step so you can see kind of like where you can find ways to make your code more efficient and shorter. I also am throwing this up on Canvas. It's just a kind of a breakdown of the if-else function to help anybody who's still kind of struggling with what the different pieces of it are. I still see a lot of people that are leaving off that final argument of the last logical test, and so then you have errors that result in that. So this is just kind of a really like thorough breakdown of exactly what every single piece of the function is. So we're going to import our most recent data set. Obviously run the Rio package if you haven't already. There's also a little further down, we're going to actually open up the full ANES data set, which I'm also putting on Canvas. Everything should be in the week 6 module or linked into the week 6 module when you go to download all of this stuff. So it's good practice to be as efficient as possible, because aside from just saving time, there's lots less lines of code, and so there's lots less places to make error. We started off just renaming variables in the first homework, and then we moved on to recoding them in homework 2. This was kind of a learning curve on our part. It's going from SPSS to R. It's really easy to just rename and label all the values and such in SPSS without actually recoding. It's kind of like 2 different steps. Whereas here in R, it's just way more efficient to do it all in one step. So the first thing we did was this, which creates a new variable in the data set called conservative. And this, I figured I'd just go ahead and we'd create this since we talked about in class last week that this is a better way to code ideology than what we had done before. So then this code here recodes the variable the way we want it, getting rid of the missing values, and then recoding this 99 to 4, the midpoint on the scale. So that is, 2 steps, whereas really we only need to just do this 1 step, because we can create this new variable and recode this old variable into the new variable all in 1 step. However, this code is actually still pretty inefficient. Since the scales are all running in the same direction, or in the direction that we want, we don't need to recode the values for 1 through 7. We're going to keep those. So we just need to set the NAs to missing and then recode that 99 to be the midpoint of 4. With the caveat that, remember, we want to make that decision carefully. Pretty much most of the time we're going to use ideology as a control variable. So this saves us a lot of cases, and that's what we want to do. If you're ever going to use ideology as a dependent variable, then you'd want to code them as missing. I can't really think of an instance where you'd want to do that, but I'm sure maybe somebody out there sometime does. We also need to recode all of the value labels, or we don't need to recode all the value labels in the ANES codebook. So actually look at the variable, or look at the data, because you don't need to write code to recode values that aren't actually in your data. ANES may list, 4 or 5 categories of missing data, but your data set may not have all of those. So if we run this table real quick, we see in my data anyway, we don't have any -8s. We only have -9. So that tells me that I don't need to bother recoding -8. I'm going to show you in a minute. There actually are two observations in the entire data set that are -8. So If you do have a -8 showing up in your data, don't run this next code here yet, because it'll not recode it properly. So really all we need to do is recode that -9 to NA and the 99 to 4, and then this piece just retains the original value. So what started off as 9 lines of code are now down to 2. And then this is my example. So I actually put this whole data set out there, but mine's in some other folder, not in my working directory. So that's why this is all long. You'll want to replace this with probably just the name of the data set, since you should have it in your working directory. But you see we've got 8,280 observations of 1,300 variables. This ANES data set is actually huge. And if you look at the full table for ideology, you see these couple of -8s down here in your console. So if you have those two observations, this is going to be the code that you want to run to set -9 and -8 to missing, and set 99 to 4, and then retain all other values as what they are. And then, I didn't actually run that. What did I do? Oh yeah, this is. So when you guys get it, this will be right. I just had it backwards. Dyslexic when I was typing, I guess. 200. Yeah, these are right. What is happening? Oh. Okay. I do need to run this. There we go. Now everything is, the -8s and the -9s and the 99s are all gone. Another thing to keep in mind is the equal sign is not the only operator that we can use right here. So for example, in age, we're gonna take a look at the data. You know, remember this is this really long. We have these 34 -9s and then everything from 18 to 80. This is how we recoded it in week 1 or 2, whichever week it was that we recoded it. And the code was pretty simple, so this would be a good, solution for this particular data. But what if we also had like a bunch of -8s and -5s and -2s and 99s, and we wanted all those categories coded as missing also? We could do this right here, which is, 1, 2, 3, 4, 5 lines of code. Lots of room for error again, but we did say, this would work. So you've got, if the original variable is -9, or if it's -8, or if it's -5, or if it's -2, or if it's 99 missing. And if not, retain the original variable. But like I said, this isn't the only choice we have when we're setting up this logical test. So if instead we say if the original variable is greater than 18, since we want to retain everything between 18 and 80, and if it's less than or equal to 80, then retain the original value. And if not, then set everything else as missing. So again, in 2 lines of code versus 5 lines of code, we've kind of done the same thing. And then also note the use of the AND operator here. We've been using OR quite a bit, but when we've got multiple categories that we want to recode in this, or recode into the same category, that's when we would use the OR. But if we have multiple criteria that the new category has to meet, then we can use the and. So it's got to be greater than or equal to 18 and less than or equal to 80. Just basically always be on the lookout for ways to shorten your code.